Hey, 20-1s. Here's a quick lesson in trigonometry about angles in standard position. First thing I want you to do is make sure that your calculator is in degree mode. So go into your settings and make sure you're in degree mode, not in radian mode. We'll talk about radians in grade 12. Okay, before we get into angles and center position, I just want to do a quick, real fast review of how we label triangles from grade 10 or even earlier, hopefully. So I'm just going to label this triangle randomly A, B, C. So the vertices are capital letters. And then remember your sides, we label them opposite like that. So that would be little a, that would be little b, and that would be little c. So that's how we label triangles. Vertices are capitals, sides are little letters or lowercase letters. Okay, so the other thing, the big skill that you learned in grade 10 was your primary trigonometric ratios, which on your calculator look like this. They look like sine, cosine, and tangent. Okay, and what we learned in grade 10 is the sine of an angle theta is opposite over hypotenuse. The cosine of an angle theta is adjacent over hypotenuse. And the tangent of an angle is opposite over adjacent. Okay, so when we use sine, cosine, and tangent, our calculator is helping us find the ratio of the side lengths. And if we wanted to find an angle, what we're going to use is we're going to use sine inverse, cosine inverse, and tangent inverse. Again, the word inverse in mathematics means we're undoing something. So they're undoing sine, cosine, and tangent. So most people have memorized the little mnemonic device, SOHCAHTOA. And there it is. Okay, so you probably remember all that. And let's just jump into a couple questions, and we'll use Pythagorean theorem as well. So let's solve this triangle. Okay, so it's a right triangle. I notice my symbols kind of shuffled down for some reason there, but it's a right triangle. So the only time that we're allowed to use SOHCAHTOA, sine, cosine, tangent, in that form, and Pythagorean is when we're in a right triangle. We'll learn in the next lessons what we do when we're not in a right triangle. So to solve, what that means is find all missing sides and angles. More than one way to do this, but what I'm going to do here is I'm going to find side F. So what formula am I using? Well, I don't have A's, B's, and C's. I know a lot of people write it as A squared plus B squared equals C squared, but I don't have that. So I'm going to rearrange my formula to fit this triangle. Then I'm going to sub in my numbers. And again, I always want you showing the formula you're using. Show me what you're doing. Okay. It's amazing that after all these years of using this basic formula, I'll see students make mistakes in grade 12 doing this on their diploma. And now I'm going to square root because the square root is the inverse of squaring, so it undoes it. And we're going to round usually side lengths to the nearest tenth. And there it is. So there's side F. Now it makes sense that side F is a little smaller than 14 because 14 is the hypotenuse. Okay, let's find our angles. And again, the order in which I find these two angles doesn't matter. I'm just going to find this angle down here. Okay, so I'm going to label it theta. So I'm going to say if I want to find theta, now I know all three sides. So I could use sine, cosine, or tangent, but from angle theta, or from vertice theta, this side would be opposite, this side would be adjacent, this side would be hypotenuse. So I'm going to use the measures that were given to me in case I made a mistake finding F. So I'm going to use opposite and hypotenuse. So that's sine. So sine theta is opposite over hypotenuse. Sine theta is 7 over 14. And then what I'm going to do is I'm going to take the sine inverse of both sides, right? When I was a little guy, my teacher always taught me what I do to one side, I do to the other to maintain equality. Sine inverse and sine theta undo each other. And now all I need to do is just pick up my calculator and sub that in, and I should get 30 degrees. And once I know that angle, well, angle up here for vertex F, I'll call it alpha. Well, now I know that alpha has to add to 180, so I can guess right off the bat that that's going to be 60. There, we solved the triangle. Now, one thing I want to talk about here is I'm going to go and plop all these measurements into this triangle. Is we all know that the hypotenuse is the longest side. What I want you to notice is another little fact. So we said this angle down here was 30, that's 60, and this side length was 12.1. Okay, I want you to notice this. We all know this. The hypotenuse is the longest side. Well, the reason it's the longest side is because it's opposite the longest angle. Guess what? The side opposite the smallest angle is the smallest side, and the side opposite the medium angle is the medium side. So you've got a way to check your work at the end. There it is. Okay, so there's just a quick review on us using some basics from grade 10. Let's do it one more time. So in triangle DRW, sure, whatever that means, it says angle R is 90 degrees. So that's the right one. It says side R is 12, that's that one. And then we've got these two other ones, doesn't matter, D and W. So W is 7, and we don't know what little d is. Okay, there's our triangle. Okay, let's solve. Again, we could solve in all sorts of ways, doesn't matter. I'm going to find side D first. So again, that's Pythagorean, right? So it's going to be d squared plus w squared is equal to r squared. Always show your formula. D squared plus 7 squared is equal to 12 squared. D squared is equal to, so 144 minus 49 sounds like 95. And D is the square root of 95. And again, we usually do side lengths to the nearest tenth, so that's approximately 9.7. There it is. Now, let's find some angles. So let's switch to pretty pink. Let's find this one down here. Let's call angle D theta. Okay, gotta make sure the Greeks are happy, so let's find angle D. So that's the symbol for angle, if you remember. So let's find angle D. So angle D, again, I'm going to use the information that was given to me. So from angle D, that's adjacent, that's hypotenuse. So on this one, I'm going to use cosine. So cosine theta, or you could say cosine angle D, again, really don't care. I'm going to take the cos inverse of both sides, because what I do to one side, I do to the other to maintain equality. Those undo each other. That's what an inverse is. And there we are. And again, we put that in our calculator. It's performing a massive operation for us. And we end up with, to the nearest degree, 54 degrees. And so now we can easily find angle W. I'll call it alpha for giggles. Well, it's got to add up to 180. So we've got 90, 54. So this one here then is going to be 36. There it is. Okay, so there's a quick review for you from grade 10. What's an angle in standard position then? Well, an angle in standard position is this. We've been used to kind of drawing these things in any orientation we want. We just throw it down on the page and we're happy with it. But if you watch my history of math of trig video, we know that the history of trig actually has us thinking, starting right here at the origin and looking up at the heavens, trying to figure out how far away things were. So we're going to stop drawing triangles all over the place wherever we want. We're going to draw it on the Cartesian plane. And that is what's called an angle in standard position. Okay, so here's how it goes. Again, think of the sun. It rises in the east, it sets in the west. So if this is where the sun starts, the Babylonians would have said that's 0 degrees. So we originally start right here at 0 degrees. That's our initial position. That's our initial position. That's where we begin. So now we're going to rotate 60 degrees. And we rotate 60 degrees in this counterclockwise manner because we're actually following the path of the sun. And we stop right there. So 60 degrees is how far we traversed. There it is. Okay, let's do this again. So for 200 degrees. So again, we originally start right over here at 0. And now we've gone 200. Okay, so we've rotated. There's 180. So we're a little bit past 180. We're right there. That's 200 degrees. So what I want to notice, though, what's really important is this measure right here from the x-axis to our hypotenuse, or it's a circle, our radius. What's this measure right here? Well, to get that measure, I'm going to say I traveled 280 degrees, but that x-axis on that part of the Cartesian plane is 180 degrees. So that little angle in there is 20 degrees. This is what's known as our reference angle. Okay, and that is going to be incredibly important as we go through this unit and really important in 30-1. Okay, so the reference angle is the measure, the acute angle from where we end up to the x-axis. Okay, let's try another one of these. So 110 degrees. So we start over here at our initial arm. We rotate, right? The sun moves around. 110 is going to be somewhere over here, and we stop right there. There it is. Okay. And so where's our triangle? Well, our triangle is going to end up being right there. See that triangle we just made? It's a nice acute angle. So the angle we traversed right here is 110 degrees. Our reference angle, let's do it in pretty pink, is this angle right here. So to find that reference angle right there, I'm going to say RA for reference angle is 180 minus 110. So that reference angle right here in the corner is 70 degrees. Okay? And I should note as well that where the arm stops, this is known where we stop. It's where we terminate. It's the terminal arm. So initial means where we're starting. Terminal means where we're ending. Reference angle is this acute angle that we get to the x-axis. And like I said, it's going to be very important as we go through. Okay, let's look at the last one here. Negative 330. Well, what would that mean? Well, that would mean I'm starting over here at 0 degrees, and for some reason the sun's going backwards. I think we got ourselves a bit of a problem, right? We're in a lot of trouble, but we're going backwards. There's negative 180. There's negative 270. So we're going to come all the way back over to here. So when I see that negative, friends, it just means we're going clockwise. And if I were to draw my triangle now, I'm going to always draw my triangle to the x-axis. And it's a right triangle, just like that. Okay, so what's that reference angle there then? Well, I want you to think, if we've gone 330 around, well, there's only 30 degrees left that we could possibly go, isn't there? So that's our reference angle. So these terms are going to be very, very important to us as we go through. So initial arm, where we begin. Terminal arm, where we end. Angle in standard position means we're drawing it on the Cartesian plane. Standard position. And reference angle is the acute angle measured to the x-axis always. Okay, we're never going to draw a right triangle that goes to the y-axis, always to the x-axis. There you go. Angles in center position, done.